I am Professor Sangeeta, Department of Computer Science and Engineering, Karpagam College of Engineering. In today's lecture, we will discuss about basic concept of compiler design. We know basically the main aim of compiler is to convert high-level language to low-level language. The question is, to convert high-level language to low-level language, why don't we write a program in low-level language? The reason is we are not comfortable of writing program in binary language, that is zeros and ones. We are comfortable of writing program in uh, English language or some other language which is similar to English. So a compiler is a computer program that transforms source code written in a programming language into another computer language, then later takes binary form known as object code. It creates an executable program. So compiler converts source program into a target program. Translators. Translators can find and detect the error during translation. So there are three translators: compiler, assembler, interpreter. As we know, a compiler is a program that translates a high-level language, for example C, C++, and Java, into low-level language, that is object program. Assembler is also another translator which translate an assembly language and convert an equivalent machine language. The third translator is interpreter. Line by line execution is taking place. If there is an error in the statement, the interpreter terminates its translating process and displays an error message. Compilation and interpretation. Interpretation can have greater flexibility and better error messages can be generated, dynamically create code and then execute it. The interpreter is 5 times slower than compiler and it requires huge memory. Interpreter languages are Perl, Python, Java, Basic, Unix Shell. Then come to compilation, will give better performances compared to interpretation. The next one is language processing system. Compiler convert a high-level language to low-level language. Along with the compiler, many other software module which helps to convert high-level language to absolute machine code. So here we have a preprocessor, compiler, assembler, linker and loader. So the high-level language is given as an input to preprocessor. The preprocessor convert high-level language into pure high-level language. So we must know what is high-level language and pure high-level language. If you are writing C program, the starting line contains hash include and hash define. A program contains such a line is called as high-level language. So what the preprocessor will do is, the preprocessor is going to remove all these lines, removing by including the file inclusion. So the preprocessor will substitute the entire file into your source program. So the high level language is given to preprocessor. The preprocessor will remove all tags and converting into a pure high level language. So sometimes you might want to define constant value, but it is a variable one. Therefore, manually every time we cannot change the values inside the program. So you can just define some constant, then it's automatically changes, is called macro expansion. So macro is a small function which really don't want to call, but instead of using the function is overhead, so we are calling the macro is very simple one. Now the pure high level language is given input to compiler. So the compiler can convert pure high level language into assembly language. So the assembly language is not exactly machine language or high level language. It is intermediate. So assembly language contains mnemonics, for example, move, add, subtract. So now the assembly language is given input to the assembler, then convert into a relocatable machine code. So an assembler for one platform will not work for another platform. So here the linker and loader. So the machine code, relocatable machine code is load the machine code at any point in computer and run. So here the loader and linker. The loader is an operating system component that loads and executes file into your memory. The linker is a computer program that combines and links many object files to create one executable file. So finally, the loader and linker will generate a absolute code. So absolute code is loaded at particular location in memory. So this is language processing system. In this course, we are not looking at all the tools. We are looking what the compiler to do. So structure of compiler. There are two parts to compilation. One is analysis and another one is synthesis. Analysis, it takes source program as an input and determines the operations implied by the source program, which are recorded in a tree structure. Then the synthesis part, it takes a tree structure and translate into a target program. So here the source program is given input to the analysis and convert into intermediate code representation, and that can be given to synthesis part, then it is generated as a machine code. So the analysis phase is called as front end of a compiler, then the synthesis part is called as the back end of the compiler. Phases of compiler. So we have the source program is given as input to lexical analysis, syntax analysis, semantic analysis, intermediate code. So all these phases is called as front end of a compiler. Then optimization and code generation is called back end of the compiler. So along with the phases of compiler, we have a symbol table and error handler. So we will look at what each phases will do. The first phase is lexical analysis. So this phase, it is used to scan the source code as a stream of characters and converts it into a meaningful lexemes. So that is, it represents these lexeme in the form of tokens. So the lexical analysis gives the tokens to input of syntax analysis. Now the syntax analysis takes token as an input and it generates a parse tree or a syntax tree. Then now the syntax tree is given input to semantic analysis. So semantic analysis, it checks whether the parse tree constructed follows the rules of languages or not. Then the semantic analysis given input to intermediate code generation. It is between high level language and the machine language. Then the code optimization phase. So code optimization and code generation is back end of the compiler. Code optimization is removes unnecessary code lines and arranges the sequence of statements in order to speed up the program execution without wasting resources. So resources are like CPU, memory. Then the code generation takes the optimized representation of the intermediate code and map into a target machine language. Then finally we have a symbol table. All the identifier names along with their types are stored here. So whenever it requires, it will take from the symbol table. So we have a error handler phase. It handles a error which is generated by each phase.